Azure AI Search with autonomous Copilot Studio agents. I've been using this for a while. Let me start with quick intro the agenda. I will explain why RAG, because more or less every agent that I build today, I'm using Azure AI Search. Real world use case, high level workflow. I wanted to put the architecture, but it was too big to put into one slide, and then we will have live demo. So quick information about myself. I'm Microsoft MVP for Copilot Studio and M365 Copilot. I help our customers to deploy and extend M365 Copilot. I also architect custom engine agents in Copilot Studio and Foundry. I provide a lot of training around Copilot, Power Platform, and starting from May, you will see a lot of content from me for Agents 365 because I'm also a technical lead for Agents 365. And I also provide governance and measurable ROI for our customers. So I want to start off with why RAG. So RAG stands for Retrieval Augmented Generation. It's very important for agents that we build for enterprise use cases. So today, if you use any agent, or let's say if you use ChatGPT, if you don't have your own data, as a user, when you submit the prompt, that directly goes to large language model, and large language model using its trained data or web will generate the response for you. And it will have no context unless you provide that data. Otherwise, it's just gonna be basic information. But with RAG, we have more control over the agent response. So when the user sends prompt, before LLM gets that prompt, that's sent to vector database. And in this scenario, we are using actually Azure AI Search, and Azure AI Search can index data from our SQL database, Azure Blob, SharePoint, etc. And that sits in a different index. It's basically a physical copy of our data from these data sources. And then it adds that context to the prompt itself. It's basically embed that. And then that augmented prompt sent to LLM. Now LLM has better context and the generated response is more accurate. And this is especially important in the autonomous agents because autonomous agents, you have just one shot. The agent needs to get the right content and generate the response. Otherwise, you are basically wasting the time. So let's look at the real world use case. So by the way, all the data I'm sharing today is fictional, but the project itself, real world project I delivered. So the use case, this is a large insurance company, and this insurance company has 50, 60 carriers. Each carrier submits their, let's say, daily accident dates, policy information using Excel file. Excel file dropped in SharePoint. There is Logic app, takes that information and sends that to Azure Data Factory. You will see that information in the following slide. But the problem is sometimes these carriers change the field names, and that basically breaks our data ingestion pipelines. And fixing that is extremely manual. Imagine we have 50, 60 carriers, and each carrier has 65, 70 fields. So that's a lot of manual work. And then solution is using autonomous AI agent in Copilot Studio. So whenever there is a mismatch field, that would trigger the agent. Agent using Azure AI Search would find the relevant information or relevant chunk, then send that to prompt tool inside Copilot Studio. Then prompt tool will basically create the suggestion, send that to SharePoint, and then human will review it and accept or fix it, and then that will be added to metadata table. So let's look at the high-level workflow. So as I said, data comes to Azure Data Factory. If there is no problem, it will send that directly to metadata table here, you can see. Otherwise, if there is a mismatched field or unknown field, then it will store that information in SQL, which is our staging table here. As soon as data drop there, that will trigger the Copilot Studio. And in Copilot Studio, I'm using built-in trigger. And then Copilot Studio, the agent will take that incoming payload and will send that to Azure AI Search. Azure AI Search has its index from the metadata table, and it will find the relevant information and then send back to the agent. Agent will use the topic and store that information temporarily and then send it to prompt tool. Prompt tool will create a suggestion and send back to the SharePoint using agent flow, and then human will review and either approve or fix, then approve, and that will be added to SQL table. So there is actually an app, but for this demo, I'm using SharePoint list. But in a real world scenario, you would use, let's say, Dataverse with model-driven app. So that's been said. Let's go ahead and start it. Let me showcase. So here is the Copilot Studio agent. And so as you can see, this is triggered when a new schema drift is detected. If you look at the backend, it's very simple. All I added here, additional compose action, because if you don't do it, it will send back to you the entire payload, and you don't need, you just need to highlight which columns gonna be helpful for the agent. And that's what I'm sending to agent. And as soon as it's detected here, the agent will follow the instructions here. This is very important. Again, like we don't have a chance here to tell agent, hey, go ahead and fix it. No, we need to be very specific in our instructions. And here is I'm saying receive trigger, and you will be triggered by this specific trigger. And then please store the incoming payload in this variable. And I'm gonna show that to you as well. And then I'm saying search the knowledge base using this specific knowledge base, which is Azure AI Search. And this is very important. Here I'm saying apply a filter to limit results to the same carrier. So if the carrier exists, make sure that you focus on that. Otherwise, if you don't find, then fall back to global search if needed. And then store the search results, save the search results, another global variable. Then generate mapping recommendation. I'm making the tool call here, which is a prompt tool. Then the store recommendation to another global variable. Then use topic level agent flow to store that in SharePoint. And here is the SharePoint, as you can see. Let me make it a little bit bigger. So here is the carrier name. Let's say submit insurance, line of business, source column, destination column. So agent maps this, looks at the carrier, finds and says that, hey, this looks like semantically similar. And then it puts all this suggestion, it gives the confidence score, and it also explained the justification why it decided that this is the best approach. And then status, and human would come here, review it, approve it, and so on. So let me run it for you. So here is one of my recent triggers. All right. So let me extend this. So as you can see, I'm getting specific fields rather than getting the entire fields. And here, the first topic, as soon as it's triggered, immediately captures the payload. And we need to be careful here because the agent has the context window limitations. So I'm passing context from one tool to another tool. And then it starts the search. So let me actually close this. So here you can see it did search using Azure AI Search, and it also logged the search results in another global topic. Then it sends that two inputs to our prompt tool, and then log the prompt tool information another topic, and then use this specific topic to call the save the results in the SharePoint. So let's look at the top tools that I'm using here. I have one tool, which is prompt tool. Let me extend that. And here you can see I have two payload. One is the original payload, another one is the search. And then I'm giving the specific instructions. And based on the instructions, I'm saying, look at the semantic similarity. And then output is, as you can see, it's the JSON format. And I'm getting these outputs. So I'm saying, keep the original source column name, source carrier name, a line of business, and then also find the recommended destination column, recommended line of business, recommended carrier, provide the confidence score and justification, and additional guidelines that what are the limitations that it needs to be aware of it. So once this is stored, I have topic, which is log outputs, and this is using the agent flow. Let me also show this to you. So even though I'm getting the JSON output here, I had some issues. So instead of sending like parsed values, I'm sending the entire prompt tool outputs, and inside the agent flow, I'm using the parse JSON to store that information. So as you can see, the agent flow gets the outputs as a one out input, and then I'm using parse JSON, and then using the simple create item in SharePoint and mapping these fields, and that's how it works. And let's also look at the Azure here. So in Azure, I have, this is the Azure Search Index that I created. And let me give sample example. I can say date of loss, and it would look and it would find the similar information. And I can also use filter. I can use like different metadata information, and that's why it's very powerful. And typically Azure AI Search stands for two things. First is the accuracy, and second is the speed. So this kind of agents, especially in autonomous agents, we need to make sure that it's fast enough so that we don't see timeout. And here is the simple like fictional database in SQL. I have two tables. One is the metadata table. So incoming payload needs to match with this. Otherwise, it will send to the agent, and agent using prompt tool will create a suggestion. And here is the incoming payload. So as you can see, carrier name, line of business, source column, and so on. So this is the information I'm sending to Azure AI Search. And I want to be clear here. When we use Azure AI Search, the prompt is not sent to the original data source. There is index. So the prompt comes to index to search and finds the relevant chunks. And creating the index, it's super easy. All you need to come here. You need to have resources and go to import data. And from here, you see you have all these the different sources like Azure Blob Storage, Data Lake, Azure Cosmos DB, Azure SQL Database, and if you use SharePoint, you can also use Logic Apps and etc. So that's the way I use Azure AI Search for autonomous agents. So let me actually show the one last thing here. So I like the term called business relevant IT. So whatever we do, it should serve either reducing the cost, improving our revenue, or making us more compliant. And this resulted for the company reduce manual effort. It's more scalable because we can have more carriers and unknown fields, and the agent will take care of it. Mapping accuracy, it has better context rather than someone manually doing it. And also we can govern and trace every input that or result that it created by agent. So that's it from my side. Back to you, David.